Hello, thank you for joining the Texas Instruments New Product Update webinar. Just a reminder that this is a weekly series every Thursday at 10 a.m. Central. A few quick announcements before we get started. This webinar will be recorded and available online at ti.com/NPU. All phone lines will be muted, so if you have questions, please use the chat box and we will try to answer in real time, or you can contact your TI salesperson or field application engineer. Today's topic is Advancing Intelligence at the Edge. I will now pass it over to Vaibhav for introductions.
Hello, everyone. Hopefully, all of you can hear me. Okay.
Yes, you sound great.
Awesome. Thank you. So, hi, I'm Vaibhav Mahimkar. I'm the AI software product manager across the processor business unit. And today's topic, thank you for the opportunity, is for me to present to you our latest offering on AI product portfolio on the processor side. So with that, I'll get started. Loosely, the agenda that I plan to follow is an introduction to our latest platform, covering the various devices and the products available in that and what the platform would entail, and primarily focused on what the developer ecosystem is. I'm sure you'll have a lot more information that is available for you from each of the product pages regarding what the device contains, but my objective is to give you an overall view of what the platform entails and what it means to have a scalable ecosystem for development across the various devices that belong to this one platform. So honestly, we are very excited to bring this latest offering, which is one platform consisting of multiple devices and a complete ecosystem for one-to-multiple camera systems. It's the AM6XA Vision AI processor platform. The A in the end means it is an AI accelerated series of processors. What it means, it's a platform consisting of the right hardware for intelligent or AI inference models. It's one platform that consists of multiple devices. It allows you to have or enable applications that require all the way from one camera to multiple cameras. We cover all the way up to 12 cameras with the series of devices that we have, and we'll go over each one of them. Everything that I will be showing today, each of the resources, including the products and the software ecosystems, is available through ti.com/edgeai page. So all the slide deck information, if you start out through this page, you will be able to discover similar components online, and you can browse freely and understand what the offering is. Okay. So I'm sure we all come across a variety of video or vision-based products across day-to-day life. Consider it as being an application inside the home or an appliance which uses camera, a vacuum robot, or a lawnmower, or some of the services and goods that we use, they are enabled by these systems that use vision-based systems, maybe a warehouse, maybe a delivery bot. All of these systems are becoming smarter. When we say smarter, as in they are able to identify the objects and respond accordingly in real time. So they need to have the right vision processing and inference model. That's what artificial intelligence or detecting the object in front of you really means. You need to have the right hardware and the pipeline to do that in real time. And that's what makes these systems smarter. But one more thing that we notice is each of these scale from maybe a single camera system with the right power performance constraint to maybe operate in a battery constrained environment, all the way to a fully autonomous system. Think of an AGV that is able to have a surround view of the entire path along with radar or LiDAR information to get information about the depth and perceive the path accordingly to have a fully autonomous system. So we see the application scaling all the way from the lowest end to the highest end in terms of numbers of cameras, in terms of the performance requirements, and to be able to operate at the right power consumption levels. So with this need in mind is what we have brought out this portfolio. One platform consisting of 3 different devices, and each of them purposefully built such that it meets the entire spectrum of the needs of camera-based applications. What we enable is easy selection through our web pages and ability for our users and customers to be able to identify what is the right product for their application and how to get started with the development easily. As I said earlier, our devices span from enabling 1 all the way up to 12 cameras. We are beginning with 3 devices that are being launched already. They are available on ti.com along with the entire software ecosystem. Beginning from the leftmost, the AM62A, which enables either 1 to 2 cameras. It can go all the way up to 4 cameras, but we deem it fit to be up to 2 cameras with RGB or RGB IR kind of detection. These are targeted primarily towards very power efficient battery operated applications that require performance with AI acceleration at the right battery performance level or the power consumption. As we go to the right, we have AM68A. That gives you a little more power performance and it allows you to connect all the way up to 8 cameras to the device itself through CSI. On the rightmost end is AM69A. It brings in more CSI lanes and more CSI interfaces that lets you connect up to more cameras. It's a fully autonomous system. Each one of them brings in the right combination of ARM core, which is A53 on the left side, and then all the way to right, multiples of A72, paired with the right AI accelerators. And as you can see in the snapshot itself, the kind of applications and the number of cameras based on the application is suited for the right needs, and the device is catered and architected such that it meets the right requirements of that application. So what does really making an application smarter means? If you look at any of the vision-based or camera-based applications, you will see auto detection or these boxes drawn around. This is where the AI acceleration comes in. These are enabled by a variety of what we call the AI models that are available through the public ecosystem. So if you've heard the names such as TensorFlow, PyTorch, along with variety of data sets, these models are made available by the community and are ready to use or deploy by any of the vendors of silicon side. So what we do is we take in those models and we enable them to run on our devices. Similarly, anybody can use their own models as well if they want to with the right tool set that we have made available, but we make it very easy. You do not have to be an AI expert to be able to run these kinds of smart applications on the device. These are readily brought in and made available. Along with the models, we also make some ready-to-use examples that are available. People or users can get started with those, swap in different models, see for themselves what the performance looks like. Typically, these models have a lot of MAC operations, and that's what makes a regular processor core not suitable to run this typically, unless you are okay with a very slow frame rate. But think about a real-time application where you want to understand and take real-time action, navigating a bot or a vacuum robot that has to navigate something coming in its way, dodge some objects. That requires real-time performance. This is where acceleration of these compute-heavy models with the right accelerator that is provided in each of these devices comes in handy. That's what enables the real-time response, and the application tends to be smarter because of that enablement. So the combination of the right hardware, availability of these models, which are AI models, and being able to easily use them and deploy them on our devices, all the way from the 6.2a to 6.9a with varied level of performances and multiple cameras is what makes the performance and the scalability of our product portfolio easy for our customers and the right fit for a variety of applications. So we meet the entire spectrum with this, along with not just the hardware, but the entire ecosystem. So if you look at the lower end of the slide, it's a quick peek into what all applications could use this smartness or edge-enabled AI, so to speak. If you go from left to right, again, the number of cameras or the complexity of the application is increasing. You can find a single camera with RGB or RGB IR used on the leftmost end. As you go towards right, think of multiple cameras, somewhere surround view with more sensors added and augmenting it. We call this as a sensor fusion capability. So each of these can be met with the portfolio of devices that we have launched. Similarly, there are different classes of applications where these can be used. Think about a smart home. The few examples that we saw about a vacuum robot or a lawnmower could be smart home, or a doorbell could be smart home. In security and surveillance area, these can be scaled all the way from one to multi-cameras. A security surveillance camera in an outdoor or an intersection area could deploy multiple cameras. That's where we see our customers and users find it very helpful to have a scalable portfolio. They could start deployment on one of these application or performance target areas and easily scale the applications from one to multi-cameras, either upward or downward, or maybe add more features. So this real flexibility of not having to recode or not having to redo your development when you're moving from one device to the other is a real strength for the portfolio. And this can be utilized across all sectors of the end equipment. A little more detail about the three devices that we launched. We already saw this earlier in terms of the camera capabilities that can be scaled from 1 to 12. There is one more parameter that typically goes with the AI accelerator part, which we call as the TOPS, which is a performance criteria, which is trillions of operations per second. And the AM62A is a 2 TOPS device. If you go from to 8 and 6.9A, they are respectively 8 and 32 TOPS device. Simultaneously, they can also handle more cameras and more video chain pipelines. So the combination of the right camera requirement and the pipeline is what is matched with the TOPS performance. So the needs of these performance meet what applications these devices are targeted for. They are balanced with the right power consumption requirements for the applications as well. One of the features that AM62A brings in is the IR capability. We see this quite heavily used in applications where you want to detect little more subtle human gestures or night mode recognition. This is where the RGB IR comes in handy. There is an ISP IP inside the AM62A that allows this. On AM68A and 69A, some of these can be implemented in software as well. They do not have a dedicated hardware IP to do that, but the device is capable of handling that as long as the signal information has that. Quick peek into what kind of cameras can these devices handle. Again, these are based on the max compute that the devices can handle. As you can see, 62A can handle up to 5 megapixel cameras. These are more than enough for in-house indoor usages. Typically, 2 cameras with 2 megapixels are sufficient for that, but our device can handle all the way up to 5 megapixels. As you go to the higher end devices, each one of them can take in up to 12 megapixels. That means a higher resolution, and it can work with much more denser pictures for the detection. In terms of the frame per second, this is where examples that require much higher processing can be handled in terms of 30 frames per second on the 628. Applications such as doorbell and surveillance are more than enough using these 30 frames per second. As you go to the more complex applications, 68A and 69A bring in more frames per second. In fact, 69A can handle 2 streams of 60 frames per second. But this is a quick peek, and you will find this on the TI.com Edge AI page as well, as how these various devices compare and contrast, especially in terms of the vision or the video camera performance. There are more parameters in which they contrast, and some of the additional IPs and peripherals are called out inside the device datasheet. But these are the quick, handy ones for you to compare and figure out what is the right device for you. At the end of the presentation, we have a slide deck with clickable links for each of the devices in the product pages, and that would be handy. So as I said earlier, it is one platform consisting of multiple devices. But what we have made available along with multiple devices is a common ecosystem for development. And this is where some of the development tools, the model zoo, the software ecosystem, all of these are common across all the devices in this platform. For instance, the latest tool that we are launching is Edge AI Studio. It is going to allow users to compare and contrast the performance of the AI models across any of these devices without even having to have a board in hand. It's a free online tool. Anybody can log in and deploy any of the detection models, the earlier detection models that we talked about, which is a people detection model or identifying what kind of object is in the scene. There are ways to even identify how much of the space is occupied by a certain object, which is called as segmentation. All these various parameters can be checked by the user on various devices with this online tool for free. They are immediately connected to remote EVMs that are deployed by TI. All they need is a TI account and are able to see the performance themselves. We make all the models. We call it as a model zoo, which essentially means various models from likes of PyTorch, TensorFlow. These are industry standard names that make these models available, and we have them compiled for our devices already. So users don't have to do any of that, but just pick a model, deploy it, and see for themselves. At the same time, if they want to customize any of those models to maybe do some last mile changes for their model, let's say they want to identify a certain kind of object, certain kind of soda, maybe a certain kind of obstacle, these can be easily added by the user themselves with the tool that we have made available. It's going to come mid-April. But what it means is allow the users to customize the models for their specific applications. Customers can bring in their data, upload it to this one of the two devices and the tools, and out comes a model that can be easily deployed on the device. So now they are able to do this customization and differentiation for their application without even us having to give anything. So this is a very powerful tool that is going to become available mid-April. Again, a free tool. Anybody can use it. Anybody can compile it for the TI devices without having to pay anything. Just a TI.com account is more than enough. At the same time, we also have seen some customers who have their special models. So basically, they take some of the models and customize it or make some layer changes. This is also supported in the same tool. They are able to pick the right compile format and the target device, upload their models, and the result is an output that can easily run on the target device. So with these three different kinds of ecosystem or the flows, we have enabled complete autonomy for our customers and users, with which they can deploy and bring their differentiation. If they want to use something straight up from our models, they are welcome to use the models. If they want to customize it further, they can bring their own data and customize the models further. If they wish to use their own models, which they have made in some other ways outside TI's ecosystem or TI's development flow, they can bring that in as well and easily deploy. So this tool can be discovered from the same link. It is going to be live in April 15. It serves two purposes. It gives you evaluation and it gives you deployment. That is, it can let you develop the model or customize the model and deploy it on the TI's hardware. So this is going to become available mid-April, and we are looking forward to this. Along with the development ecosystem, there are plenty of quick and easy examples that we provide. One of the examples that we'll look into later, which is an out-of-box demo, which lets users try various models, see the performance themselves, be able to customize it and run it on the connected video camera, and a similar look and feel for all three devices. But other than that, each of the examples that are primarily used in the video industry or the vision AI side of things, which is detection of objects, detection of people, being able to classify various objects in the scene and segment the scene based on what objects are available. All these are available as ready-to-use examples. Users can follow what we call as the PyTorch, Pi notebook, and be able to Jupyter notebook and be able to deploy them on the device themselves. Easy to follow instructions are available on the edgeaiprojects.ti.com. Again, this link you don't have to copy. It can be reached from the Edge AI page that we talked about earlier. But these are all available and handy. Users can follow quick start guide and duplicate or replicate the demos on their boards. Similar to this, we also have an academy. Similar kind of link available from the Edge AI. It gives you a little more documentation or collateral view of what is available, walks you through some of the fundamentals and basics of AI, and then walk you through how to deploy it on the TI devices. So these together is a great resource for our users and customers to start out development. They are also accompanied with a lot of video and training series available, and a start page from Edge AI can take you to these pages. We talked about the out-of-box demo earlier, so just wanted to give you a feel of what that looks like. For all the three devices, each of them have an evaluation platform. We'll look at the links later. But the idea is, with similar look and feel, if users just bring in the board, connect a screen and a mouse to it, they are able to run, of course, with the power supply connected, they are able to run these example demos. It's a simple click and follow through and allow the users either to see on the pre-built videos or supplied videos how the evaluation or detection looks like, or they can select one of the cameras that is connected and supported and be able to see live for themselves how the results look like. Again, based on the device, they can go all the way up to from 4 simultaneous videos to 12 simultaneous videos based on which device they are selecting. So just a quick peek on how the start screen looks like. As soon as you connect the board, which has the right image provided by the SDK downloaded on it, you connect the screen, connect the mouse and the keyboard. This is what you will see on this connected screen. You can click in any one of these buttons and it will let you see the results on the video. Or you can go to the custom tab and select one of the connected model cameras, then choose which model you want to run on it. And based on that, it'll let you see the results for yourself. Supplied along with the camera option are packaged videos. You can choose one of those to see how the results of the performances in for the various models that we have. This is a similar look and feel, irrespective of which device you're on. Just the capability of how many videos it can run and how many simultaneous cameras it can handle differs or changes based on the device. But the objective is easy start for our customers to be able to see how the performance is. And of course, accompanied with the rest of the examples and the demos, they can continue their path of development. The starter kits for each of these devices are available. They are orderable today, and they work with the examples and the out-of-box demo that we talked about. These can also be reached from the landing page that we saw earlier, and the links are at the end of the page as well. One of the things that we have kept common on all of these is the Raspberry Pi 22-pin interface. This allows us to connect a variety of community-based cameras. So we are compatible with the wide community ecosystem that Raspberry Pi brings in, and the cameras that work with that system can now readily work with our boards as well. And this is a huge enabler for the community ecosystem side. So we talked about multiple cameras being supported. Just a quick peek of how these are being enabled with the board and external connectivity. Some of the boards that we are adding to make multi-camera systems available on the device. We talked about the Raspberry Pi 22-pin interface being available on each of these devices. So if you can see, for single and dual camera, you can easily bring in a RPI 22 compatible camera, connect them onto the boards directly, and be able to use them. If you want to bring in multiple cameras, we are partnering already with some of the third parties. You can see the names here, Arducam and Technixion. We have built a stackable 4:1 board with Arducam. These can be stacked to make a 8:2, as you can see in the octal camera, and a single 4:1 in the quad camera at the top. These together allow you to bring in 4:1 or 8:2 cameras. Based on the board that you're connecting to, these can be easily run and are available for purchase from Arducam. We will be adding more software, more cameras and support as we go forward, but these are already enabled today. And if you have more questions, you can send it to us. These are going to be available in a few weeks' time span for ready to purchase from Arducam website. Similarly, we are also bringing in a full SOM, which will allow you to connect FPD-based cameras onto a complete system. You can see a 8:2 camera system on the right side from Technixion. We are bringing some of that to AM69 board as well, which will allow you to connect 12:3 cameras to the system. So this together, along with the software connect ecosystem, is making an entire ecosystem available for our users. A quick overview of next steps to get started. Here are useful links. We talked about the technology page, which could be a starting point very well to reach any of these, any of the links and the collaterals that we talked about. The tool system, which is the Edge AI Studio, there's a link to that given here. The 3 resources for common development platform, which are the AI projects, Academy for collateral and documents, and Model Zoo, which is essentially the AI models library that is made available. And these can be reached from the landing page. If you go further, each of the product pages, each of the EVM or the starter kits, as we call them, links are available. And the software, which is Linux-based software development ecosystem for each of them, is available. So with that, I can stop and answer some of the questions. Hopefully we are doing good on time.
Yes, we did have a question that came through the chat. You may have already seen it, but it is, what is the difference between an intended application of this AM6XA and TDA 4VH processor lines?
Okay. So in general, the TDA-based processors are a little more heavier in terms of the IP integration and some of the peripherals that are added. The AM6XA is an equivalent, but with less number of peripherals and lesser power consuming IPs added to it. So some of the other elements that the TDA, either VH, VM, or AHP devices give you are a separate safety island, some of the DM pack peripherals that are required, those are additionally added to the TDA class devices. And it brings in a few more elements that the AM6XA vision-only processors may not find handy or may not want to use. So performance-wise, AI acceleration-wise, there are equivalents on both sides. But the other peripherals is where they typically differ. And of course, the power consumption and the cost is where AM6XA would be a little more feasible for vision-only applications. I wonder if that answered your question. Awesome.
Looks like we have one more question that came through the chat. It reads, is CAN FD available across all variants of AM6A, and are all the part footprints compatible? And I'm sorry, that reads AM6XA.
So was the second part, are all the parts pin compatible? Is that
yes? Are the parts footprint compatible?
Okay, so got it. Thank you. So first part, the number of cans will be based on the device. We will have to look into each of the device data sheets. The auto equivalents do bring in the can peripheral. So that would be a straightforward answer there. Each of these have an auto equivalent as well, Q100. For the pin compatibility, the answer is no, just based on the number of CSI interfaces and the other peripherals that are needed. The footprint is different for each of these devices. So hardware-wise, you may have to change the board, but you can come up with a SOM format that may be the same, and that's what some of our third parties are doing. The Technixion board that we saw, they keep the motherboard the same. On top of it, they change the daughter board for the device-specific one, and the rest of the software stays the same. The biggest advantage for the devices is the scalability for software developers. Whatever they develop on one device can easily be duplicated or extended for multiple cameras on a higher end device. I think that is what gives us the scalability, to be honest. Okay. Kelly, was there anything else at all?
No, looks like that are all the questions. Thank you.
Okay.
All right, and thank you everyone for attending today's MPU webinar. The recording and PDF version of the slides will be available at ti.com/MPU. See you next week for our next topic. Learn about TI's leading power density ICs for space grade power management. Have a great day.